Pressure in a water tower comes from gravity, the pump, and a combination of the two.
The gravitational force comes into play by creating constant pressure on the water storage.
Hydrostatic pressure is one of the types of pressure.
Hydrostatics is the science of fluids. The equation for hydrostatic pressure is P equals the density of fluid times the acceleration due to gravity, which is 9.8 meters per second squared down, times the height of the liquid plus atmospheric pressure.
Pressure loss due to friction comes from four different things: velocity of the water, inside diameter of the pipe, roughness of the pipe, and length of the pipe.
The flow of a liquid is the amount or volume of water moving through a pipe, with units as gallons per minute.
Water towers are a good, reliable source for a town. Water in the tank has high potential energy.
The water towers are built on high ground and built very tall, so there's enough water pressure for the tower to work.
Each foot of height is about 0.43 psi, or pounds per square inch, of pressure. A typical water tower is between 50 and 100 psi. A normal in-ground pool holds 20 to 30,000 gallons of water. A water tower will hold 50 times that amount.
The pump station averages by itself about 500 gallons of water per minute.
Before pumps were invented, windmills were used to pump the water up to the tower.
If the pump itself cannot provide enough water for the town and all the needs, the water storage has a day's worth of water which can be used to provide water. This usually happens in the morning when most people are getting ready for school and work. When the pump provides excess water that is not needed in the town, this water is pumped up into the storage tank. This is because water cannot be compressed and it has to go somewhere. The water tower gets its water from the water treatment plant and goes into the pump. The pump then pumps water either directly into the town or city or into the water storage area for later use.
Due to the height, there is high potential energy in the tower, so the water has enough energy to make it back up the pipes as long as they are not higher than the tower. This can be explained by PE equals mgh. Potential energy equals mass times acceleration due to gravity, which is 9.8 meters per second squared down, times the height.
Because of the law of conservation of energy, the water stored in the water storage facility has potential energy, and because of the height, the energy as the water moves down the piping will be able to go uphill to any pipe as long as it is not above where the water started in the water tower.
Today we are doing a basic demo with a toilet paper roll, some tape, saran wrap, and plastic piping. We took the toilet paper roll and put saran wrap on the bottom, and then we stuck the plastic tubing up the saran wrap and wrapped tape around so the water wouldn't fall out. Then we'll put water in so that we can prove that the water there is more potential energy at the top than there is over here.
The potential energy that is stored in the water up here will be converted into kinetic energy, but there will still be enough to convert some into potential energy as it goes back up this part. When we put water in the top, you will see water bubbling out the bottom, which proves that potential energy and the law of conservation of energy work. This proves that the potential energy in the top of the water tower helps the water tower get water through all the pipes, even ones that have to go up.
It's cold.